we are now in a position to define an integral. So we say a function f from AB to R is said to be Riemann integrable on AB if there exists L in R such that for every epsilon greater than 0, there exists a delta that depends on epsilon, which is also greater than 0, such that if P dot is a tag partition with norm of P dot less than delta of epsilon, then mod of S of f P dot minus L is less than epsilon. So intuitively, a function is Riemann integrable if the limit of Riemann sums exist as the norm of the partitions tends to 0. However, this Riemann sum is not a function of the norm of the partition. Hence, this is not a limit in strict sense, but still it is good to keep this intuition in mind. The set of all Riemann integrable functions will be denoted by RAB. We will now show that if a function is Riemann integrable, then the condition in the definition is satisfied by a unique L. So assume L and L dash satisfy the definition and let epsilon greater than 0. Then there exists delta that depends on epsilon by 2 such that if P1 dot is a partition with norm of P1 dot less than delta of epsilon by 2, then norm of S of f P1 dot minus L is less than epsilon by 2. Also, there exists delta dash of epsilon by 2 such that if P2 dot is a partition with P2 dot with norm of P2 dot less than delta dash of epsilon by 2, then mod of S of f P2 dot minus L dash is less than epsilon by 2. Now let delta star of epsilon be equal to minimum of delta of epsilon by 2 and delta dash of epsilon by 2. And P dot is a partition with norm of P dot less than delta star of epsilon. So for this particular P dot, the P dot will satisfy both these inequalities. That is S of f comma p dot minus L, mod of that is less than epsilon by 2. Similarly, mod of S of f comma p dot minus L dash is also less than epsilon by 2. Because of this, if you look at modulus of L minus L dash, modulus of L minus L dash is equal to modulus of L minus S f p dot plus S f p dot minus L dash, which by triangle inequality is less than or equal to mod of L minus S of f comma p dot plus modulus of S of f p dot minus L dash, which is less than or equal to epsilon by 2 plus epsilon by 2, which is equal to epsilon. But as this inequality is true for every epsilon, this means that L and L dash have to be equal. And this proves our result. This uniquely determined L will be called the Riemann integral of f. So L is equal to Riemann integral, and it will be denoted as integral a to b of f, or it is sometimes denoted as integral a to b f of x dx.